Welcome to Sundar's lecture. This is lecture number 94, and in this lecture we are going to see line and phase currents and voltages in delta connected loads, right? See, what are all the topics we have seen in the previous class? See, we have taken some problems related to star connection, and we have concluded so many things, right? In star connection, what is line voltages and what is phase voltages and what is line current and phase current, all those kind of things with the help of the equations whatever we have derived in the 92nd lecture, and we have taken all the equations and we have implemented for the problems, and we have solved all the problems, right? So now in this class we will go for delta connected system. See, this is nothing but delta connected system. The basics of the delta connected system we have already seen, and you see here what is which one is the line current and phase current here. See, whatever the current coming in here, that will be line current, and whatever the current flowing through this load impedance, we are calling it as the phase current, right? We know that already. So here, so IR will be maybe IR comma IY and IB, IR, IY and IB, we generally call it as line current, right? So next one, you see here whatever they see, what is the way we are taking here, the voltage between these 2 points. Maybe if you go like this, the current, we always take, see, VRY, we always written it as VR minus VY. Try to understand, we always try to write like this, but here both are equal. Anyway, I will explain you a bit later, but we will take like this. So what we are telling here, the current will flow in this direction, so that this expression will satisfy. Try to understand, this expression has to satisfy if we are minus Vy, this expression should be like this. So like that, if you go for Vyb and also Vbr, whatever it may be, it has to be satisfied. So always we will write Vyb will be is equal to Vy minus Vb, right? And then if you are writing Vbr, then the expression should be Vb minus Vr, right? Try to understand, and then only you can easily satisfy this. So with the help of this one, if you try to apply the KVL, you will get the expression. This current should be like this, and this current should be like this, and this current should be like this. So this is the current direction. You try to understand, because we are taking the expression VRY as like this, right? So now you see here, one thing is very important. What is the voltage between, what is the line voltages? Line voltages, which is nothing but it is the voltage between these 2 points, right? And what is the phase voltage? Whatever the voltage between these 2 points, this point and this point. See here, R is coming here, Y is coming here, and what is the voltage between these 2 points? The same thing. It will be same, right? So the expression for V line should be is equal to whatever it may be, See, VRY or the voltage across this ZP will be same, right? I can write it as V phase. Try to understand, because these 2 points are same. And if you measure whatever the voltage across these 2 points, it is the same VRY. That is nothing but we are calling it as phase voltage too. So line voltages and phase voltages in a delta connected system, it will be equal, same, right? In star connected system, the line current and phase current would have been the same value. And now what we will do, we try to write the expression. See, I am taking this current to be IRY because this is flowing between RY, and through this load I am taking this current to be IRY. Right, now you just apply KCL at this particular node. What you will get, summation of current, whatever the current is coming in, IR is coming in, right? IR is coming in, and then you see IBR is coming in. So it has to come here, IBR, and then you see this IRY is going away from the node, so it is IRY, it is going. See, right, you have to understand everything, right? This is line current, and what is phase current? I have already told you this is line current. And what is phase current? Phase current is IRY, and then IYB and IBR. See, you don't confuse, it is not the line current. So this is nothing but we are calling it as phase currents. Phase currents. Try to understand. See, in the notation, it will be little bit confusing because VRY there we have taken it to be line current, but IRY here we are taking it to be phase current. Try to understand. That is why I have written here. See, this is the expression. Now you see, if I want to find what is the value of IR, that should be is equal to IRY minus IBR, right? Can you understand? And if you apply KCL here, whatever the KCL you apply here, what you will get, I will directly write anyhow. IB is coming in, IB is coming in, and IYB is coming in, and IBR is only going away. So you will get IB should be is equal to what is going away? It is IBR is going away, and then coming it is IYB, right? So you will get an expression like this, and if you are going to apply KCL at this point, IY is coming in, so you will get IYB is going away, and this is also coming in, so it will be IYB minus of IRY. So these three are the expressions for line currents. See, this is line current. Try to understand. This is nothing but line current. IR, IY and IB are line currents, right? So we have written the expressions, and we need to know what is the value of IRY. What will be the value of IRY? It is also very easy. See, what is IRY? What is the current here? What is the voltage across these 2 points? Nothing but it is VRY. It is VRY divided by, what is the value here? It is EZP. It is EZP. Maybe you can write like this. See, I can generally make this to, I am just generally making it to VRY by ZP. I am just taking it to be IP. Generally, I phase current. I phase current. See, this one, I've just told you, this is nothing but a phase current, right? IRY is nothing but a phase current, and what is the value? It is VRY by EZP. See, always I will take this as reference value. If this is the reference value, I'm just taking it to be a reference value, and what will be IYB will be is equal to VYB, IRYYB divided by ZP, same load, because this is balanced load. So what you will get, this will be also IP, but since it is ABC sequence, I have already told you what is ABC sequence. If it is ABC sequence, IRY, then IYB, then only IBR will come, and you have to write, if you take this value, and it will be nothing but minus 120 degree, minus 120 degree. And if you divide this one now, it is VBR divided by ZP, and you will get IP the same value, because VRY, VYB, VBR, everything it will be same value, everything it is equal because it is a balanced load, so you will get an equal value. So it will be minus 240. Right, now we got all the values. Now it is very simple, right? You just substitute in this expression to get what is IR, IB and IY, and what is the relation between the phase current and line currents. We can easily find it out, right? That we will see. I will take it to the next page. See, I will just now substitute this value. So IR will be is equal to, what is this value? It is IP. It is IP at an angle of 0 degree minus IP, that is BR, right? It is BR. So IP at an angle of minus 240 degree, right? I will get an expression like this, right? And if you further simplify this, you just take IP commonly outside. If you take IP commonly outside, what you will get? It will be 1 at an angle of 0 degree minus 1 at an angle of minus 240 degree, right? So if you simplify this, so IR will be is equal to, maybe I will get it as IP, that is phase current, into root 3 at an angle of minus 30 degree. Right? You just simplify this. You just simplify and just convert this one. You will get obviously this value. Right? Now I have found what is the value of IR. So right now what maybe I will go for IYB2. So next sorry IB. What is this one? I will go for IB. So what is IBR? IBR, it is nothing but IP at an angle of minus 240 degree, and then minus of what is this one? IYB, it is IP at an angle of minus 120 degree, and you just take commonly outside, again same principle, you just follow, it is minus 240 degree, and then minus 1 at an angle of minus 120 degree. You just simplify this, obviously you will get IB to be, it is IP at an angle of minus 150, right? Am I right? Yes, I am right. It is minus 150 degree. And then if you are going for again Y, if you are going for IY, then what is IY? It is IYB. It is IP at an angle of minus 120 degree, minus this value IRY. It is IP at an angle of 0 degree, right? So again same thing, take IP commonly outside, it is 1 at an angle of minus 120 degree, minus 1 at an angle of 0 degree, and if you further simplify this, IY will be is equal to I phase voltage, I phase current, minus 270 degree. Right, am I right? I will check it out. Yes, I am right. It is minus 270 degree, right? So now this is the value. These three, where it is. I just missed out this root 3. Root 3 into multiplication of this root 3 will come. There, here it is, right? Root 3 will come. Right, now you see we have got all the three values. We have, it is multiplied by 3, multiplied by root 3, right? Now we have got all the values. See, if you draw the Phasor diagram, what you will get? See, I will draw it down. See, this is nothing but, if I am taking it to be IRY, See, I am just taking it, I have taken this as the reference. So apart 120 degree, obviously what I will get at 120 degree, I will get IYB, because it is RYB sequence, ABC sequence or RYB sequence, everything is same. And then if I am drawing this one, I will get an expression, a small one, right, this value. Now what is this one? This is nothing but it is YB, it is IBR, right? It will be IBR. Now you see one thing. See, what is the value of IR now? It is nothing but the phase voltage. This is so you see here, this is nothing but phase voltage, right? So this IR is lacks the phase voltage and multiplied by root 3. See, magnitude will increase and it lacks the um, phase voltage, phase current by 30 degree. So what it will be, maybe if I, even if I draw the diagram, see, it is very simple. See, what is the value of IR now? It is IRY minus IBR. So if I just take out this one at the negative side, so what it will be now? So this value, it is very simple. What is this one? It is minus IBR. Maybe I have to have a space here. So minus IBR, right? This is minus IBR. And what is this one? The addition of these two will give you what? IR, right? So where it will come now? So addition of these two, and the magnitude is root 3 times, right? The magnitude is root 3 times. What it will be now? So magnitude is increased and this is root 3 times. So what is this value now? This is nothing but it is IR, and if you add these two, you will get the final answer. And what will be the angle between these two? This is nothing but 30 degree lagging, right? This one is coming first and this is lagging now by 30 degree. And what is the value of the IB now? IB, it is IBR. I am taking, this is IBR, right? IBR will be there, and IYB has to come now. IYB, negative IYB. So if I draw this, negative IYB will come here, right? What is this value? This is negative IYB. This is negative IYB. And what is this one IB? It has to be addition of these two. Addition of these two. Where it will come now? So obviously it will go in this way. So what is this value? This is nothing but IB. And you have to add these two values. These two you have to add. And what is the angle between these two now? Again the same thing, right? What is the angle between these two? That is also 30 degree. That will be also 30 degree. Try to understand. Maybe this one not exactly like this, maybe it will come like this. Anyway, I will draw the next one. See what is the next thing. Next thing you have to go for IY, that is IYB will be there. IYB will be there and minus of IRY. It will come like this, right? Minus of IRY. This will be minus of IRY. So this will be minus of IRY. And if you add these two, what you will get? Obviously, you will get this value of IY. So you will get IY. So if you add these two, obviously it is root 3 times, right? It is root 3 times. And what is this value? This is nothing but it is IY. And you have to add these two values. This one and this one. And what is this value now? What is this value? This is 30 degree. See, this is 30 degree. So what I can conclude here, see, try to understand one thing. I can conclude that, see, IR, what is the value of IR? Which is nothing but this is line current. IR is line current, right? This is line current. Always see line current value will be higher than the phase current value. So IR, I can generally write it is root 3 times the phase current, root 3 times phase current, root 3 times the phase current, but lags IRY by 30 degree. Try to understand. This has to be understood very clearly, right? I will take it to the next page. Again, I will tell you what happens to, maybe I will copy this too, because I have to write for all the things. I have to write for all the things. Maybe I will go here. I have to paste it out. See, this is the same thing. It will come for all other things. Which one? See, IY again. That is also line current. That is also a line current. That IR, sorry, that IY will be root 3 times phase current. Maybe which phase current? See, this phase current, it is IRY phase current. And this phase current, this is nothing but IYB phase current, but lags IYB by 30 degree. By 30 degree, see here, which one I am telling? IY. See what happens to IY? IY, this is lagging, right? Because it is coming like this in the clockwise direction. You see this is coming first, so it is lagging, right, by 30 degree. Then obviously what you can write it down. Then if you are going for IB, that is also line current. That is also line current. And IB, which is nothing but it is root 3 times. It is root 3 times phase current. Root 3 times the phase current, or it nothing but it is IBR. So now that is IBR, but lags IBR by 30 degree. See here. This is root 3 times higher, but lags the IBR by 30 degree. See, this is how you need to understand. See, in star connected system, the line voltages leads the phase voltage by 30 degree. Root 3 times higher. There also maybe if I go over there so that you can easily understand. You have to compare. That is my point. Where it is, see, we would have derived it and we would have written it finally. See, BRY here, it is line voltage, leads the phase voltage by 30 degree, and also VRY will be root 3 times higher than the phase voltages. Same thing. There also in delta connected system also the line voltages, line current the line current, maybe I will have here, the line current will be root 3 times the phase current. But here it lacks the phase current by 30 degree. Try to understand. There it leads, here it lacks, right? So this is the difference. See, if you take a star connected system, if I am taking star connected system, star connected load, maybe I just need to compare these two things. Maybe I will take perfectly right here you see the line current will be is equal to phase current. See, try to understand line current, maybe I will write it down fully. I line will be is equal to I phase whatever it may be. Maybe IAN will be is equal to maybe not IAN, IRN will be is equal to IRY. And as I'm just giving you an example here, and then you see here the line voltage will be is equal to root 3 times phase voltage, but here the line voltage maybe I will write it down. Line voltage leads the phase voltage by 30 degree, which means I can write it in another hand. That means VRY will be is equal to VRN, that means root 3 times VRN at an angle of 30 degree, that will leads the value by 30 degree. Like that, if I am going for VYB, it will be root 3 times VYN. This also leads by 30 degree. And also if I am going for VBR, that also root 3 times VBN, and it will leads by 30 degree. Try to understand. I am just saying with this with this values, with these which means this phase voltage, with respect to this phase voltage, this line voltage will lead by 30 degree, right? That is why I'm just writing like this. And if I'm going here V line will be is equal to V phase in delta connected system, which means maybe VR, here there is no neutral point, so VR will be which is equal to VRY. That is one thing. And if I am going for I line in general, I line will be is equal to root 3 times I phase. Try to understand, right? But here the line current lacks the phase current phase current by 30 degree. Try to understand very clearly, because it is very important to understand too. So here IR, which is equal to root 3 times IRY, but here the angle will be minus 30 degree. And then it is IY, which is equal to root 3 times IYB, but the angle will be minus 30 degrees. See this one, it is very interesting to compare star and delta. IB, and then it will be root 3 times IBR and at an angle of minus 30 degrees. Right? So this is the relation between star connected load and the delta connected load. And with this conclusion, we try to solve many problems related to delta connection in the next class, and we will have some more thing, some important note. That means I will write it down. Z why, maybe I will tell you in the next class anyhow, because I need to, if I start here I have to continue this lecture. It is not possible to continue, and I cannot complete it by time. Maybe I will tell you in the next class, that is what is the relation between star and the delta impedances. If I if what I can do, how I can convert the star into delta and delta into star if three impedances are same. That is an equation 3 times higher. Always Y connection, maybe star value is higher than the delta value by 3 times. And that proof we will see in the next class, and then we will see some problems related to delta connected load, and then we will have some comparison problems with the star connection in the next class. See, you just go through this one. This page is very important, and you just compare this one, you will get the answers, right? Thank you.